Dear students, in the previous lecture we discussed about what are intelligent agents and different kinds of environments. Now the current lecture will discuss about structure of agents. Structure of agents. As we already discussed that every agent has sensors and actuators. Sensors perceives environment and actuators perform actions. The job of AI program is to design agent program that implements the agent function mapping percepts to actions. If a program will run on a computing device with physical sensors and actuators, we will call it as architecture. So, an agent is equal to architecture plus program. Let us discuss about agent programs for 2 minutes. An agent program take the current percept as input from sensors and return action to actuators. The agent program takes just current percept as input because nothing more is available from the environment. If the agent's actions depends on the entire percept sequence, then the agent will have to remember the percepts. Table-based agents. Generally, information comes from sensors through perceiving, that means percepting, and triggers actions through effectors or actuators. The mapping from percepts to actions will be stored in the form of a table. Actions not only depends on the current percept but also on percept sequence. A table is a simple way to specify mapping from percepts to actions. It is known as table-based agent. Table-based agent consisting of two columns. In one column we will write perceptions and in another column we will write corresponding actions. They will be stored in the form of a table. It has several drawbacks. Tables may become very large. All work done by the designer, that means no autonomy for agent. All action are already predefined within the table. The agent has to follow. Learning might take very long time, and mapping is implicitly done by the program either by using rule based or by using neural network based or by using algorithmic based. Types of agents. There are four basic types of agents in order of increasing generality. The first one is simple reflex agent. Second one is model based reflex agents. Third one is goal based agent. Finally, fourth one is utility based agents. All of these agents can be generalized into learning agents to improve the performance and generate better actions. Let us discuss one by one. Simple reflect agents selects an action based on current state only, which ignores percept history. If we look at schematic diagram of simple reflect agent, where the conditional action rules allows the agent to make connection from percept to actions. The agent diagram shows two kinds of symbols. First one is rectangles shows current internal state and ovals shows the background information. The sensors perceives about from the environment and which identifies what the world is like now, and it will do actions based on conditional action rules. Let us take a small example of vacuum cleaner agent. Previously, we discussed several rules. The same several rules are converted into conditional action rules. If the state is dirty, then the vacuum cleaner has to suck the dirty. Else, location equal to A, then the return right. Else, the location equal to B, it has to move left like this. Simple reflect agents uses conditional action rules to map perceptions to actions. The algorithm of simple reflect agents. Simple reflect agents takes input as perception and returns output as actions. based on some static rules. The static rules are given in the form of condition and actions. The interrupt input function generates an abstract description of the current state from the percept, and rule match function returns the first rule in the set of rules that matches the current state description. The agent will work only if the current decision can be made on the basis of only the current percept, that is, if the environment is fully observable. Model-based reflex agents. The most effective way to handle partial observability is the agent to keep track of the part of the world it cannot see now. The agent should maintain some sort of internal state that depends on the percept history and thereby reflects at least some of the unobserved aspects of the current state. For example, for driving tasks such as changing lanes, the agent needs to keep track of where the other cars are if it cannot see them all at once. The internal state depends on the percept history. The model of the world based on two characteristics. They are how the world evolves independently from the agent and how the agent actions affects the world. The knowledge about how the world works, whether it can be implemented using Boolean circuits or it can be implemented with scientific theories, is called as model of the world. An agent that uses such a model is called as model-based agent. The figure shows the structure of reflect agent with internal state, showing that the current percept is combined with the old internal state to generate the updated description of the current state. Here, the agent is going to combine the current perception with old history. Then they will going to take some actions based on conditional action rules. In the previous slide, we observed that the structure of reflect agent with internal state showing how the current percept is combined with the old internal state to generate updated description of the current state. An interesting part of this algorithm is in update state, which is responsible for creating new internal state description as well as interpreting the new percept in the light of existing knowledge about the state. It uses information about how the world evolves to keep track of unseen parts of the world and also must know about what agents action do the state of the world. Goal-based agents. Knowing the current state of the environment is not enough to decide what to do, whereas we should also know some sort of goal-based information. For example, decision taken at a road junction while we are moving on automated car. The agent needs some goal information that decides the situation that are desirable. An agent program combines the goal information with the environment model to choose the actions that achieves the goal. Sometimes goal-based action selection will be more tricky when the agent has to consider long sequence of twists and turns to find a way to achieve a goal. At that time, we have to go for searching and planning mechanisms that are subfield of artificial intelligence devoted to finding actions sequences that achieves agents goals. Consider the future with what will happen if I do an action A. Utility based agents. Sometimes achieving the desired goal is not enough. For example, a taxi ride. If we go to the destination in a quicker, safer and in a cheaper trip to reach the destination. An agent's happiness should be taken into consideration. We call it as utility. A utility function is agent's performance measure. A utility function maps the state onto the real numbers, which describes the associated degree of happiness. The complete specification of utility function, which allows rational decisions into two kinds of cases. The first one is when there are conflicting goals. That means only some of which can be achieved. The utility function specifies the appropriate trade-off. Whereas when there are several goals that agent can claim for, but none of which can be achieved with certainty, then utility function provides a way in which the likelihood of success can be weighted against the importance of the goals. Learning agents. According to Turing, instead of actually programming intelligent machines by hand, which is too much work, build learning machines and then teach them. Learning also allows the agent to operate in initially unknown environments and to become more competent than its initial knowledge. Four conceptual components about learning agents. First one is learning element. Learning element is responsible for making improvements, which uses feedback from critic on how the agent is doing and determines how the performance element should be modified to do better in future. Performance element is responsible for selecting external actions. It is what we considered an agent so far. Critic, how well is the agent is doing with respect to fixed performance standards. Problem generator allows the agent to explore, and he is also responsible for suggesting actions that will lead to a new informative experiences. References. Our prescribed textbook is Artificial Intelligence, a Modern Approach by Stuart Russell and Peter Norving. The prescribed edition is second edition, but in the market we are having fourth edition by PHS and Pearson.